I can't remember who I'm stealing this line from, but I am going to steal it. I am going to bombard you with information over the course of the next 49 minutes because that's what this class is about. If anybody listened to Craig this morning, he went over a lot of technical stuff that was, I'm not going to call it painful, but he was hitting you with a fire hose of information. Hold my beer. Right? I'm going to do something similar to that, but at the same time, no, I'm not. I'm going to go over some stuff because my goal right now is not to teach you anything. I want to go over some topics that are misunderstood, misplaced, that kind of a thing, when it comes to what I like to call the math of HVAC. I'm a math guy. I was a tech for a long time, and I learned how to fix things. But I needed to fix situations, and that's where the design part of it comes in. I start to get into very specific things when it comes to air conditioning or heat pumps or furnaces in people's houses because the math matters. The idea of sizing something based off the square footage of a, you ready? Unit dwelling. Why did I say that? Why didn't I just say a house? Right? Because you might be doing a condo. Right? I'm showing off my ASHRAE prowess right there. That's what that is. I don't know. Is that funny or is that stupid? Right? You can tell me the truth. I don't care. I had somebody before tell me I was borderline unapproachable. Right? And I was like, what? I'm a goofball. You can come up and tell me whatever you want. In fact, I get as much, if not more, enjoyment out of somebody telling me I'm an idiot because of something I said, because if I say it in public, I'm going to be right, because I'm not going to open my mouth if I'm giving my professional opinion on something, because it has to be right, because where does my world come from? Say math. Math, right? So 2 plus 2 is always going to equal 4. So we're going to follow all those rules as we go through this stuff. Now, this is my first time using the Q, and let's see what it does. Oh, look, the PowerPoint's already started. I'm also used to standing right here and looking at it, and I can't. And trade secret real quick. I'm not wearing my glasses. Does anybody remember why I don't wear my glasses? Yeah, I can't see. Past the first row, you could be sticking fingers up at me or looking like you sucked on a lemon from something I said. Doesn't matter. All I see is a blur. So if you ever end up presenting, you don't have to pretend people are naked, because that's gross. But you can not wear your glasses or get glasses that decrease your... Yeah, put on a pair of cheaters if you don't wear glasses. So that's a little tip from Ed. All right, we're going to talk about the residential design series. If you're not familiar with them, they are our books, our being ACCA, and we have a bunch of books that will give you a big hand when it comes to sizing, which is the first one. Manual J is BTUs in and out of a residential structure. The second one is Manual S. That's going to tell you how much airflow is supposed to be moving across a ducted system. Could be how many BTUs you need if you're doing a hydronic system. And it tells us what piece of equipment to select. There's this bizarro land thing going on where people say, oh, I did a load calc, and then they immediately tell you what size piece of equipment that they're installing. There's a big disconnect in our industry when it comes to BTUs, right? It's not just about tons. If we're talking about air conditioning, it's sensible BTUs, it's latent BTUs, right? It's not just tons. There are times tons come into play, and if you want to talk about a 2-ton unit, I'm fine with that. I don't want somebody to say it's 18,000 BTUs of sensible and 6,000 of latent. Did that add up right? I'm showing off my math skills right there. So, but that's the way that works. There's things that need to be very specific. There it is. That's the, well, I don't even know if I'm allowed to say it, but screw it. Redhead stepchild of the whole design series right there. Grills and registers. What's the #1 reason that grills or registers get selected? Based off of what quality? Appearance, right? And is that wrong? Yes. Yeah, it's wrong. But more contractors do it that way because they simply don't know. And we're going to elaborate on that. And hopefully it's a little bit entertaining or funny, or both. And then last one is ducts. I love the whole ducts subject. I ran into a guy at ASHRAE last week who said his TikTok got more views from the short video he put up where I said you can't have a duct that's too big. I had no less than 30 people call me an idiot. And I love that because I want to have a conversation with that person. Because I know, based off of math, that I can defend that statement in its context. And before the end of today, might be 15, 20 minutes into lunch, I'm eventually going to defend it. All right. We have I can't remember the name of this document, so I'm going to call it the review form, and that's just where I'm going to leave it. That's a review form. That's for you. That is for a code official. That's for anybody that wants to accurately follow the design series. It does not ensure that you are doing a perfect design. It is there for aiding someone in code compliance, and code compliance is at the pinnacle of a design or workmanship. It is a starting point. It's a minimum amount of information to collect in our case, or it's a minimum of how a job should be done. I have had many instances where this form has swayed the opinion of an AHJ, which is code speak for authority having jurisdiction. All right, we're not going to call it that anymore. We're going to say the code official. So the code official might be very more likely to accept what you're trying to explain to them with the use of this. On the opposite sides, we have entire counties that they give you this when you submit or prior to you submitting a permit, and they have you fill this out. Now, I know a bunch of you guys are going, what the hell's a permit? Right? And that's a reality in part of the country. It might be a reality in part of the country, but if you're in the unfortunate circumstances of sitting in a courtroom because you grew mold in somebody's house or you did something incorrect, there's going to be a PE sitting there grinning from ear to ear, and he's going to have done his due diligence. He's going to have completed that and more, and he's simply going to say, they did it wrong. And you're going to have no defense, get your checkbook out, and I hope you never end up in that situation, and that's the end of that story. Whew, guess I should have worn my glasses. We're going to go over the obvious, the misunderstood, how the review form. I'm going to show you actually how to use it. We're not going to spend more than 5 or 6 minutes the entire time on the review form. Then we got things you knew and some things you didn't. So we're going to do some fanny patting. We're going to hear some, or at least I hope we are, when it comes to a few of the things that we're going to say. I can't read the last one.
You got it. Surprise.
What's that?
What you're surprised about.
Oh, yeah, you're going to be surprised. So that's the way it goes. Starting off with the design series. What is the point, or a better way to put it, what's the goal? Anybody got any idea? I love that answer, right? And comfort is one of those things. I'm going to do this right now. If you're selling comfort, if you don't, in your contract, have the definition of comfort, you deserve that kick right in the jimmy. Because if you tell somebody that you're going to make them comfortable and they're not 70 degrees and 30% humidity, they bring the pain, you deserve every bit of it. Because if you're going to say comfort, you have to define it. And in my world, comfort is going to equate with some very specific numbers. So what are those goals that we're looking for? It's going to be 70 degrees at design in the wintertime, period. Next, in the summer, it's going to have a 62-degree wet bulb in the house. And Russ is over there saying, yeah, but it's really 62.5, because if you want 75 degrees and 50% RH, that's the way it works out. That's why some manufacturers publish at 63-degree wet bulbs and some at 62, because nobody can make up their mind. So I just go with one and leave it at that and do that little brief explanation. We're trying to maintain a specific temperature and humidity in the summertime. And there's a hard stop behind that, simply for the fact that if somebody says they want to be comfortable, we got to define it, right? So you get why I said that now. And is it a Manual J goal? Where was my guy that wanted to, he had sunglasses on and I don't see his face right now. Somebody wanted to answer that, and I'll pick on Adam because I know him. Is it a Manual J goal? Say no. No, he's absolutely right. What is it? It's a design series goal. Everybody's got to be in the pool. That's a good man. If I need them, I will put, but I don't want to see anybody's faces in like the second and third row. So thank you, Jim. That was very nice of you. It's a design series goal. If you don't use all of them, you can't expect to get these, and I'm going to use the P word for the first time today, and this is one of my favorite things. Any idea what the P word is? Predictable results. I'm all about math, right? And I want 2 + 2 = 4. I want predictable results. You follow the guidance in these books and manage your expectations with what these books can do, you're going to get those predictable results. All right, Manual J. That's the book we're going to use. And I can't emphasize enough when it comes to Manual J, you have to follow the rules. Follow the rules, follow the rules. Table 1A, and this is the part where I'm going to start going a little bit faster. And I had this all figured out before I started. One of the reasons I'm going a little bit faster is I'm going to use a slide like that, and I'm going to talk about it briefly. For those viewing at home, or when you look at this on the video later, you can hit pause and read all the text that I'm actually talking about. So, when we look at Table 1A, these are our design temperatures. Our design temperatures consist of 99% of the days during the year or 1% of the days during the year where we're going to see temperatures go above or below. We don't design for worst case scenario. It's that simple. Air conditioning. Air conditioning is the bane of my existence. People want a bigger air conditioner. What happens to the air conditioning system when we have part load conditions compared to a design day? It runs less. Is it harder to get moisture out of the house if it runs less? Was any of that difficult? But people still want bigger air conditioners. And let's just call it what it is. That's stupid, right? With the electrification that's taken place, the powers that be are pushing all these heat pumps. I love heat pumps. I got 2 in my house. They're sized properly, eh? Can I dehumidify with them well? Yes, even at part load conditions for reasons that I'm not going to go in detail with. I'll be at the booth later here. If you want to talk to me about it, we can discuss it. We end up with systems that don't remove humidity as they should on part load conditions because we can't see the forest for the trees. My brother-in-law Bob has a 2.5 ton, and I'm going to get 3. Nothing to do with the house. I want something bigger. And we kind of had that squashed again. And then with the heat pump stuff, my market, Mid-Atlantic, they're putting 4 tons of heat in with the heat pump and expecting it to cool a 2-ton load. And it'll make it colder. You'll have fuzzy stuff in the house, too. And I'd be lying if I don't find this kind of entertaining. Because who doesn't like being I told you so? So that's how it works. So there's the form. We use the form, and all the pertinent information from Table 1A gets populated right there along with name and address and all that kind of stuff. This form is really nice to force you. I love the forced word. Force you to follow the right process. So we got a house there. Manual J, it's going to have, and I can't believe I'm doing this. What do we got? Is that table B? At the top is, is B and C. And we're looking at a glass door. It acts just like a window. And if you got skylights or something like that, that's worksheet B and C. Then we got worksheet D, and is that the opaque surfaces? Again, I had somebody come up and say that I was kind of unapproachable, and he said that I was knowledgeable, and I kind of laughed. It took me every bit of 5 years to understand what the hell opaque was. I had to Google it every time. Is that see-through or not? I had to keep looking it up. Why that word was used is beyond me, but it's there. Next is infiltration. It's another worksheet. We have appliances. Guess what it is? It's another worksheet. Why did I use this image? Because it's got the fan above the cooktop on it, right? And it's not a forehead greaser. It's actually going outside. Do you size your equipment because it's in the house? It's a hard no. If you have a giant exhaust hood and you're worried that you need an extra half ton of cooling, what are you supposed to do? Put a unit unit in to service just that. The bottom line is intermittent loads don't go against your count for BTUs in the structure. It's simply just the way it is. I want to remind you, I'm not trying to teach you this. I'm doing a very high-level view of this stuff. I'm trying to convince you to come hang out with me in a couple weeks when I do a class here, or if you're really driven, I'll be in Salt Lake next week doing this. So, but it's cold here. It's really, yeah, he's got the face. He's sucking lemons. No, it's not a good thing. Ductwork is in Manual J. You have to account for it. Did Mahali show up in here? Go to the ECM motor guys over here on the corner. That picture on the right there, they're his hands. What I'm trying to point out is Manual J really gets down to the nitty-gritty. It's looking at the BTUs that are required to evaporate the water as part of the load, right? Did you have any idea that it did that? The motor watts, that's why that's in there, and some other stuff. Again, I'm not going to get into the minute detail, but Manual J is your friend. They've done a very, very comprehensive mathematical calculation, and it's your part to put the best information in there that you possibly can. Then we get into this one. I love this one. This is the one to me that screams, hey, you need to read the book, right? Because I have, and this is a rant that I'm going to go on briefly. There are more people, and I talked to somebody who sometimes people tell us we look alike. I don't know if you guys know Alex Meany, but he gets called Ed, I get called Meany last night, right? This happens. And I threw this number at him, and he said I was exaggerating. And I made this statement. 10% of the people that do load calculations have learned Manual J from Manual J. 90% of the people that have done load calculation have learned it from doing load calculations, and to me it's very obvious because they'll make these statements like, Manual J oversizes the heat loss on a house. Well, if you ever actually open the book past like the 12th page, it tells you it's going to do that. It's really that simple. It is it's a process where we're trying to hit a moving target, right? How easy is it to hit a moving target? It's not. So when Manual J was written, what are they hitting? A stationary target, right? We're going to ensure you're going to maintain 70 degrees. And all the math that goes into it has a range. And they're going to pick the top of the range because that's always going to be it. What's the word I'm looking here? Thermal mass. I've heard Manual J does a terrible job with thermal mass. Well, explain what a good job would be. Because in the summer, it does because it's part of the calculation. But in the wintertime, is a house going to absorb heat into that masonry mass in that house and reject it to the house when the sun goes down? Yes. Do you live someplace where it's possible you could go for 3 days in a row with no sun? How do you model that? Well, it's a rhetorical question. You don't. So when we get numbers that might be higher than people suspect, it would behoove them. There's a big word, right? It would behoove them to read the book because it tells you it's going to happen. So I manage homeowners' expectations. I manage contractors' expectations. So what should be what happens. So this is a big one right here. Does using tight average or loose, is that a good way to determine the leakage of a house, right? And there's people get really carried away with this at times, and I love it because I'll say, oh, just read the book. It'll tell you what to do. No, well, they never saw that. They've seen sort of definitions in a software program. And there's my way to say it gives them heartburn. And using those definitions alone should give you heartburn. But what can you do? You can read the book, and it tells you to use the latest and greatest building science that's available to you. Is that a better path? Absolutely. There is no reason you would not want to do that. In fact, here's my buddy Super Tech Johnny, and he knows to do a blower door test, so why wouldn't you do a blower door test when you can do something that's more accurate? Right? That's the way it's supposed to work. That's the way you should do it. This gets into some very specific stuff. At home, pause to read. If you're watching this online, pause to read. But the moral of the story here is if you're going to use a blower door, you've got to tape off the ducts, just like you're doing a duct leakage test, because your duct leakage does not count as house infiltration. It's another example how you can inflate the numbers if you don't read the book. It's, in my mind, a very simple concept. All right, and again, pause to read, and it'll point out continuous ventilation counts as part of our heat loss or heat gain. Intermittent doesn't. Honest and aggressive. There's 2 pages in Manual J that are my favorite. Dr. Bales is doing a thing about undersize and air conditioning. I have no idea what he's going to talk about, but without knowing it, we're going to be exactly on the same page. Russ King's over there, and I'm going to try and keep this as short as I can. I read stuff that he published 10, 12 years ago, and I was like, I don't know who this guy is, but I'm right, because he's agreeing with me. And then within the last 4 or 5 years, I've met Russ, and it's like, wow, I really did align myself with somebody who has a clue. And he uses all these good phrases like blow the air in the opposite direction that it wants to go because it'll mix better. Yeah, that works. It's a really good idea. You'll get more complaints from oversized equipment than you will undersized equipment. And to me, it's almost miraculous because he lives in a dry climate. So somebody who can see, again, the forest for the trees, I love that. It's somebody who gets it. And we just got to spread the word and get everybody on the same page. And the idea behind sizing an air conditioner for Manual J is we want to be tighter than the heat loss, and that is because we care a lot about part load conditions. And it actually pains me to say this the way I'm going to say it, but it's what the book says. And what the book specifically says is we're going to try and get as close to that target on a design day as we can with the, are you ready for it? With the hope that it does good at part load. Because we can't try and hit a moving target. We're going to try and be as precise as we can on a design day with the hope that it's going to work properly at part load conditions. I think it works. Personally, I've done enough of this where I've gone in bad houses and good houses, done enough testing. I believe this whole process works the way it's supposed to. And if you're going to pick one, undersize, don't oversize. Manage the end user's expectation. If they say they want it 70 on the hottest day of the year, they're going to hate me. Right? It's just, they are. It's not how an air conditioner works. And we can't change the physics of how it works. I mean, in a little bit, we can change the dynamic in the house. Go talk to Nikki over there about a dehum. Put a bigger air conditioner in and separate the sensible and the latent. That's reality, but who wants to spend an extra, $2,000 or $6,000, right? So that's it. All right, this is my second favorite chart in here to understand when people say, oh, we monitored the air conditioner, and on a design day, it kept shutting off, right? Well, this first one right here is our full sun load capacity, and there's a vertical line going up there that's shown where the two things intersect. We need a 3.5-ton air conditioner, right? Full sun. There's my 3.5-ton air conditioner. What's that line right there represent? It's cloudy. What size air conditioner do I need? 2.5. It is the exact same house. When you look at runtime, are you also monitoring how much sunshine's taken place? It's a moving target. We can't hit it. This is the reality of it. And I don't care if you're doing runtime performance or what you're doing. It's a moving target. So we shoot for a standard target, and I'm going to say in almost every case it works. And the almost every case, in the cases it doesn't work, it's in the book. It'll tell you where you should be paying attention. And to finish this thought, our latent load doesn't change on the amount of sunshine. It's the way it works. It's the physics. I think that's the right word. So when it comes to this guy right here, we can finish off the Manual J stuff, and we can put our BTUs required. And it's more than just tons. It's sensible and latent and all that. Doesn't do the whole load calc, but it does a nice job of pushing us down the path. So this is Manual S. Tells us to pick a coil, how much airflow, and what outdoor unit to select. It also tells us if you're in furnace country, limits on furnaces. It'll tell you about hydronics. That's my basement, if you were curious. And it does that real cool thing. I walk around, I'm not going to share too much other than barefoot in my house during the winter. What's Manual S really all about? And it's sizing systems that are correct. It doesn't go really beyond that. It is for that structure that we're determining the loss and gain. Somebody asked me, am I going to be talking about the new Manual S? Here it is. The new Manual S is going to give you a path where if you're trying to size for heating with a heat pump, where you can virtually, realistically disconnect the sensible and latent load, do the latent with a dehump, right? And I think that's going to make a lot of people happy. I know it makes me happy because I don't care how you do it, as long as you do it. The idea of adding a half a ton or a ton, again, whatever pain is thrust upon you, you own it because you made the choice. That's what my customers look like because I follow the math, right? We got normal and actual. I want people to get the nominal. I said normal. Nominal out of their head and look at the BTUs. I don't care what the model number is on the equipment. I care what's in the expanded performance data. That makes a difference to me. And they're the kinds of differences that we're going to see. I still get my jollies by looking at a match set that has an 036 in the outdoor unit model number, and it's producing 31,000 BTUs. It's a 2.5 ton unit that identifies as a 36. I just made that up. That's funny, isn't it? All right, so when it comes to capacity, heating is real easy because it's all sensible BTUs. When we do latent, we get into the water, and measuring water isn't really that difficult, but it goes back to when you know how to do something, it's easy. When you don't know how to do it, it's a little more difficult. It's where the confusion sets in. We can't select equipment that does dehumidification solely based off of tons, period. And it goes back to the beer can cold, and for anybody who's from this crew, they get this beer can cold reference, right? There's no reason to ballpark stuff when there's math available to actually do it. That's the moral of the story. All right, I love spending a lot of time on this one, but I simply don't have it, so I'm going to burn through this. You got to understand sensible heat ratio if you're an air conditioning person. Whether you're selling it, designing it, installing it, or fixing it, you need to understand this. I have a 10K unit, and you're going, whoa, they don't make those. What's the brand name on there? It can be any size I want, damn it, because I like easy math, right? So it's 10K. It's making 10,000 BTUs nominally. If it's operating at a 0.75 sensible heat ratio, it's probably running at a nominal 400 CFM per ton. It's going to make 7,500 BTUs of sensible capacity, 2,500 BTUs of latent capacity. Make the air go faster, it makes more total, more sensible, less latent, and it gets more efficient. I just described 90% of all the mini splits. And when I see in my market people putting mini splits in basement, I hope the pain is forthcoming. Because it's not a dehumidifier. Don't use it like one. And that's what people do. So they get what they deserve. Do the opposite. Slow the fan down. That might be a unicorn with mini splits, but maybe not. They do exist. And you can dehumidify like a champ. But you got to look at expanded performance data. You have to make sure with 100% certainty that it has the ability to do that. Or it won't. It's not magic, right? It's predictable performance. And as I just said, we manipulate that, and our sensible heat ratio changes. What are we shooting for? What's a starting point? Starting point is right there, 75 degrees, 62-degree wet bulb. It has a corresponding intersection right there at 50% RH. I know it says, and I said 0.5, but if you want to argue about that, I'll be at this booth over here, and you can say nice things to me. And to me, if you want to complain, Wes is back there, complain to him. But don't call him Wes, call him Les. He's had a little bit of a habit of some name mix-up, so we're calling him Les for the rest of the conference. We can draw a horizontal line in our psychrometric chart, and it'll tell us what our dew point is and how much water the air holds. Eugene didn't do his psychrometrics without tears yet, right? go see him. That's a really good amount of time spent. This right here, if you're not familiar with expanded performance data, and I've talked about that a few times, it's nothing more than the manufacturer telling us how many BTUs it holds, both total, sensible, and latent. We're talking about an air conditioner here. And the latent is on you, right? What do I mean by that? They tell us total, they tell us sensible, we do a little bit of math, and then we can follow the guidance in Manual S, meet the sensible, meet the latent, don't exceed the total by the 15, 20, or 30%. Now I'm going to say that again and give you a little more detail on that. So that's just showing how an air conditioner works. Up top, we're looking at the total CFM. We're looking at our indoor conditions of that 75 degrees and 50% RH. I know it says 62 WB, but we've already discussed that they're the same thing. It's showing it's 85 degrees out. Now, how many people are going to scoff about 85 degrees being an outdoor design temperature, right? I do work anywhere now, but I predominantly used to stay mid-Atlantic, southern Northeast. I used to love seeing the reaction of somebody who lives in the Hamptons. They've got a 12,000 square foot house worth $18 million, and they're telling me, well, you can't design the air conditioner to those conditions. I want it to be for 100 degrees. And I'm like, all right, well, I'll do whatever you want as long as you sign off that you own the results that it's going to produce, because that's not the way you do it. And then we would size it properly, and it would work, and there was no big shock going on there. So moving it down the line, we have our total capacity and our sensible capacity. The extra fonts that are in there show us our latent capacity. And as we slow the air down, we see our total drop, we see our sensible drop, we see our latent increase. And that's going to happen again in those next couple of blocks, because that's how an air conditioner works. Just like I said on the mini split, slow the fan down, we're going to see the total drop, the sensible drop, the latent increase. And if you get real fancy, you see a KW word in there, and that's for kilowatts. If you track that, you're going to see that the power consumption versus the capacity is going to create a system that is less efficient as we slow the air down. It's the opposite of what a lot of manufacturers try and manufacture towards, but that doesn't help us. And this is a random thought that just popped into my head. When it comes to AHRI, do we design to their conditions? No. Do we really care about the efficiency when it comes to AHRI on an installed system? No. The first thing we do is ignore what they say. But the system has to be a certified match before we start our process. This is one of those things that makes my eye twitch when people are saying, well, AHRI says, and I'm like, we're following code, right? We're standards mentioned in the code. Doesn't say anything about meeting AHRI conditions anywhere, does it? But there are people that believe that's a thing. So that's that whole managing expectations. So Manual S, the bottom line is meet the sensible, meet the latent, don't exceed the total by 15 for a single stage compressor. We got 20% for a two-stage compressor. VRV is 30%. We do heating also in Manual S. Manual S also has guidance on sizing dehumidification systems. Our blower CFM is a product of Manual S. And they have a thing in there talking about ballparking. Last thing you would expect from a design manual is ballparking of stuff. But we ballpark some stuff. And that's solely for the purpose of us being able to go into the expanded performance data. And where do we start? Some simple math. Again, I want to point out, this is a really good overview. So you can say, well, that was easy. I understood everything he was talking about. Or you're in there going, ooh, where's the furnace? What is he talking about? You just figured that out? The where's the furnace? Wednesday, Thursday, Friday? Yeah? See what I did there? I got another one of them coming up too. So when we're doing Manual S, she's going, I still don't know what he's talking about. Okay, thank you. We have the meat of Manual S goes on the review form. I'm glad I figured that out. Next, we got Manual D. And Manual D, follow the guidance, pick a fan. We're going to design, we're going to calculate the pressure losses in the circulation path. We are going to size ductwork, and that comes from calculating the friction rate. I don't care if you're a metal fan. I don't care if you like flex. Duct material means nothing to me. Volume through it means everything to me. In fact, I'm going to take it a step further and say I really don't care about velocity as long as you don't exceed it. Right? If you don't exceed velocity, you're golden. It literally says in Manual D that there is no minimum velocity. And I love making people's heads explode about that one because it's fun. There's another one. Manual J doesn't work with a VRV system. No, it says right in the book it's for constant volume systems. And I did say that word, so if you got to bleep it out, you got to bleep it out. But it says it right in the book. These people, oh, what about a system that's running less airflow? Well, then don't use Manual D. Throw some ZR in there and get the design airflow for that register that you properly selected. It all goes back to if people are following all the steps, it becomes self-apparent. Or read the book. The conclusion to Manual D is there's a lot of things to worry about when it comes to designing a system's airways. Low velocity is not one of them. I start off my Manual D class with the conclusion, so it doesn't matter. All right, what do you do in Manual D? First thing, and I love this, step 1 is to do line 4 on the friction rate worksheet. That makes no sense. That's why I embrace it, right? So the first thing is figure out which one of the ducts in our system has the longest circulation path, right? The longest supply, longest return. That's actual length plus equivalent length, and that is going, there's step 4 on there. And there's, the previous one was the friction rate worksheet. That's the duct sizing worksheet. You fill all these out. I haven't said this yet, but I want to say this right now. Do you really want to go through and manually do all this? No. You want to understand the fundamentals of all this stuff and then go talk to Russ and give him some money and use Quick Model, right? You want to find a software program that you feel comfortable with and then use it. It literally is that simple. But you can make a giant mess with a software program if you don't understand the fundamentals behind it. Trust me, I know. I've done it. The friction rate worksheet. This is Manual D in a nutshell. We want to figure out our longest circulation path or our critical path. We want to use the friction rate worksheet to calculate our friction rate. Our friction rate and using a duct wheel is more about the internal size of the duct. It's also about making sure that we have enough starting pressure. We're going to have external static pressure to start. We're eventually going to deduct our device losses, and then we are going to have available static pressure. It's all about math and ensuring that all that math gets covered. And then once we size our ducts, we end up with the duct sizing worksheet, and that's where we size everything. Again, you can do this manually. I still kind of do, but I would much more prefer to use software and let it do all the math and all the figuring for me. There are all the steps in Manual D right there at the bottom. All right, 2 questions on this one. Forget about the stuff that's written above. Where's that picture taken? And I got a prize for you. Come over to the booth. I'll give it to you. One hint, it's not that far from your house. And what am I a big fan of for people that know me? I bragged about I was there 2 or 3 weeks ago. Yeah, that's in the airplane hangar next to Soarin' in Disneyland. I am that guy on vacation that takes pictures of duct systems, right? Is that Manual D that's in that picture right there? What are the important things that it has? And one of them makes my heart go thump, thump, thump. It's got dampers, baby, right? If you're doing a duct design, or we're going to compare it to, we're doing Manual D, will duct design give us predictable results? I really don't think so, right? I see people all the time saying, oh, Manual D says this, but they're making up a friction rate. They're not using dampers. They're not, pick one of them. If you don't follow all of the rules, I have no idea what it's going to do. It might be good. It might not be good. But you got to do it all. And again, if you want to stop by and get into some specifics about duct design, I'd love to do it. But, time is my enemy, so to speak. Again, Manual D gives us the ability to fill a bunch of stuff in on the review form. And they make you say, yeah, I promise I did all this stuff. I just didn't make it up. I wish that crossed fingers was really on the form, but I added that. All right, I can't omit this one, and I am only going to steal like 2 or 3 minutes of your lunchtime to get through this. I might finish on time. First one right there. I learned this from Jack Rise, because he says this all the time, and I repeat it all the time too. In the occupied zone, don't blow air on people. Right? It makes people angry, and it should. It always makes me question the authenticity of mini splits, right? They blow air on you and they brag about it. What? Again, it's one of the things that makes no sense, but don't blow air on people. That's a graphic right from Manual T. Obviously, I added that little guy that's around. It gives us guidance on registers to pick. It doesn't tell us whether we should blow out of the floor, whether we should blow out of the ceiling. It gives us pros and cons. You pick whatever you think is more appropriate. Manual T gives us guidance on to look stuff like that up. And this is a scary, scary thing. There are people that have no idea what that is that are designing systems, right? Again, these are the people that when the pain is set upon them, they deserve it, because this is a very important part of doing a system design. I like calling it my thumb over the end of the hose. A ducted system, I can have ducts that are really big, but as long as they're moving the proper volume, that velocity does not matter. If I have the right thumb over the hose, I have the register at the end of the supply, I'm going to get that predictable throw and spread. That's it in a nutshell. Now, what I just went through in like 3 minutes, I spend 45 minutes to an hour and a half, depending on the crowd, when I explain it, when you're in person. And if you weren't paying, I'm peddling my wares when I say that stuff, right? Returns, whether they're supposed to be up or down, that's a real good argument. And I've had our arguments, and I always win because I'm right. Oh, I don't know. I'd like to talk about this more, right? The one on the left, what do we got going on? We have air with a direct shot into the motor. It's going to be loud. No matter how you slice it, it's going to be loud. The one on the right, you make the air change directions twice. It's not going to be loud, as long as everything else is in check. In check is keeping our velocity limits in check, right? Return 700 feet per minute. Don't go above that. A duct can't be too big. I love that one because it's simply true in the context of Manual D. Branch run volume matters, velocity doesn't. Again, it's got a limit. That's where it goes. And this is a chart right in Manual D, and this is the proof in the pudding. Now, I'm in Florida, and I'm going to say, do I have half the people here from southern markets? Do you see that kind of an install, right? A branch run, and then we're in a 10x4 boot blowing up. We got 120 CFM in our branch run, and we got 120 CFM coming out. Does that look more like what you do? Right, and I like this guy, right? That was my, I see what you, it's the same thing, but more of a southern market way to show it. But if you look at my duct diameter, what are the differences in my duct diameter? Vast, right? But what is my CFM in every situation? 120. You see how that register is the thumb over the end of the hose? Doesn't matter how big our hose, whether it was 6 or 12 inch, it's going through the same, dare I say, orifice, right? I think that's a correct way to explain it. People don't pay attention to this whatsoever. Or we're back to our 10% of stuff. We get away with a lot of stuff. We can do things that are a lot more precise. Adam sitting here was telling me about a system he did. What was it, 4,000 square foot house? 4,700 and you ended up going from 7 tons to 2 or something crazy like that after they did a bunch of cool stuff to the house. Mixing stories. But you can get away with a lot less capacity if you follow the rules. You're going to start making up for deficiencies in the system with capacity if you don't follow the rules. That's the reality of what we do. Being able to manage expectations of the consumer, whether it's a homeowner for most of you. For me, you're my consumer, right? I want you to understand what these books can and can't do and enjoy the results from them. And I did it, man. It's 11:59. Somebody want to mark that? Right there. That's how you get a hold of me if you need to.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.